Okay, hello. I'm still not feeling good, so I could definitely explain things wrong or make small mistakes. I always recommend studying outside of just watching the videos I make, but I can't make you do anything, so. So the first section is the domain of a rational function. Okay. Basically, when you have functions that are fractions like this, you know that they can't divide by 0, so you're looking for any kind of restrictions, okay? So whatever makes this 0 cannot be in our domain. So this isn't really different from... It's not super different from what we've been doing. So set this equal to 0. We gave the 1 a little personality. Okay, this cannot be in our domain. That is the answer. Okay? Next. And you look up dead of the time, like machines do. Still got it, I'm just keeping an eye. Okay, so this one's a little bit different because there's a square here. So if we set this equal to 0, already you should know that this is gonna get fucked up. If you square root a negative, or maybe you guys don't know this yet, the only way you can do that is by taking out an I, right? Now, that's an imaginary number, and domains of rational functions are real. They can't be imaginary, so this does not work. So there is no restrictions. There's no restrictions, so that means the domain is just this. But on my math lab, you do not put this. You put no restrictions. Or I don't know if it says restrictions. I think it says something else, but don't type this in. Pick the one that says there's none. It's like, is it singularities? That might be what it says. I don't remember. Okay, and that is that. Pretty easy. What's next? Oh, the hell math. That's what's next. The hell math. That guy, dude, he was trying to explain me how to find an asymptote, and then was like, "Here, let me put a quadratic. Let me do like 2, and then fucking girl." If you were trying to explain a topic to me, I'm gonna need you to use the smallest numbers possible, okay? Like, and then maybe once I understand what's going on, then you can start doing crazy shit, okay? Okay. So there's 2 different kinds of asymptotes. There's vertical and horizontal. You do different things to find each of those, okay? And I feel like the best way to explain this is just by doing it. So, excuse me, we're gonna do... You know, whenever I write words, I can never decide between doing lowercase or uppercase, and so it's always like a mix mash. I have OCD, okay? Give me 1 second to write this in a way that doesn't make my brain hurt. Okay. We're gonna do vertical right now. Let's get... Okay. You should know by looking at this that it is a difference of squares. So when you simplify this, that is what it is. Now to find a vertical asymptote, you simply solve for the denominator, okay? You solve for the bottom guy. So, these are our vertical asymptotes. And our domain, we're combining what we just did, okay? So these are also our restrictions, even though they're the vertical asymptotes. So the domain would be this. That would be very nice. Okay? I don't know why he did all that crazy shit. To confuse you. to hurt you. Okay, now we're gonna do one that's gonna teach us a little bit more. You remember earlier I said something about holes. That is the literal math term. Okay. Uh-oh, these two are the same. They killed each other. That's our simplified function. So with the vertical asymptotes, you always want to find, excuse me, the asymptote from the simplified version, okay? So it's not like finding the domain where you have to find, like you would have to find the domain of all of this. With the asymptote, it's just the simplified version. So the asymptote would be that, but the unsimplified version has both of those. So this guy, who is here before simplification, is called a hole. He's not an asymptote. He's just another annoying thing you need to know. Can I explain him to you right now? No, I can't. Wait a minute, what did I do down here? Okay, next. Oops. You may think that's not going to change much, but it will, because now it's not a difference of squares. So, you have to set it equal to 0. Just like in the first problem, you should know shit's about to get fucked. That is imaginary. Rational functions can't be imaginary, so there's no, I think it's singularities. And the domain is just that. But if you get this kind of problem on my math lab and it says, what is the domain? And it gives you like, on A, it'll be like write the domain in interval notation, and then B will just say no singularities. You want to hit that. Don't put in negative infinity to infinity, or else you'll get it wrong. Technically. Okay, horizontal asymptotes are a lot easier. Not that those were hard, but like, my god, they made them so hard in the video. I didn't know what the hell was going on. Horizontal ones, it's just some rules you have to remember, okay? So, let me do an example and then explain the rules. Okay, so with horizontal asymptotes, you just look at the degree of each doohickey, of each exponent. Degree is literally just the number that the exponent is, okay? So, n, which would be the degree on top, is 2. M, which is the degree on the bottom, is also 2. So one of the rules of horizontal asymptotes is if n equals m, we must take the leading coefficient of the top and the leading coefficient from the bottom and then divide them. So that would be 9 over 3, and that would be 3. So our horizontal asymptote is 3 in this case. That's one of the rules. I will write down all of the rules as we go through them, okay? Okay, we're looking for our degrees. This is a 1, and this is a 2. So n, remember, label your shit. 1 is less than 2. When n is less than m, the horizontal asymptote is always y equals 0. Every time. If n is less than m, y is equal to 0. No matter what. Okay? So our horizontal asymptote is y equals 0. See how this is a lot easier than the vertical ones? Those are a little bit more involved. Okay, find our degrees, 3 and 2, n is equal to 3, m is equal to 2. Uh-oh, n is bigger than m. Anytime n is bigger than m, there is no horizontal asymptote. Okay? There is none. So the rules are, if n is less than m, the horizontal asymptote is y is equal to 0. If n is equal to m, then you have to take the leading coefficient of the numerator and the leading coefficient of the denominator and divide them to get your horizontal asymptote. And if n is bigger than m, there is no horizontal asymptote. Those are your rules for the horizontal asymptote, okay? Now when you're typing this in as an answer on the My Math Lab, it wants you to type these in as equations. So that one we did where n was equal to m, and so we did 9/3, and we got 3. You wouldn't just type in 3. You would have to put y is equal to 3. That would be your answer. Okay? And then for the vertical asymptotes, it would be x is equal to something. So it'll always be an equation. It won't just be a value. What's next? Graphing them. The worst part. Graphs. But you see how they made that like crazy confusing? Or maybe I'm the only one that was confused. So we're just gonna take like basically the stuff that we learned, a couple of sections ago about the transformations with like the stretching, the shrinking, and we're gonna, wow, that's, you remember how I said I had OCD? Oh god. It's been worse. I've been like really stressed, and it's been a lot worse, so just give me a second. That's as good as it's gonna get. I'm gonna try to ignore it. Okay. So let me pull out the homework questions so that I can do it the way she wants us to do it. Oh man. Did we do okay, whatever. I'm just gonna do a problem. Now, I write this really big because there's so many parts to these questions she has us doing. There's 1, 2, 3, 4, 5, 6, 7. There's 7 parts to these questions. They're 7-part questions. And so I write the function really fucking big because once I get to part like 4 or 5, I've already forgotten. I've forgotten what the function is. And if you write the wrong stuff, then you get the wrong answers. Big surprise. So, in big letters. That is our function. We need to find, I'm gonna erase this. God. We need to figure out, is this even, odd, or neither? Yes, that thing you loved, it's back. We need to find the y-intercept, the x-intercept, the vertical asymptote, the horizontal asymptote, any holes if they exist. Then we need to evaluate -6, -4, 2, 4, 7, and then graph. Ha 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 ha. Okay, one step at a time. First, we must pull on our old memory. Even is y symmetry. It's when f of x goes to f of -x. No, I can't look at the blue. Odd is my double O. It's origin symmetry. It's when f of -x is the same as -f of x. So, second we touch, you forget the day you were done with love. Let's check for even first. Anywhere you see an X, put a negative X. Negative X times negative X is positive. Is this the same as the function at the top of the screen? No, so it's not even. But don't erase that guy at the bottom, because we need to see if negative f of x is equal to f of negative x. And we don't want to rewrite it because we're fucking tired. So when you've got a fractional exponent like this and you put a negative out in the front, I talked about this in one of the other videos, you can only put that negative on one side, and most of the time it's always going to be the top, okay? So that is negative f of x. Are these two the same? No. So our symmetry is neither. That's step one. You forget the day you were done with love. Okay, y-intercepts. Set f to 0. Our y-intercept is 0. Our x-intercept, I cross them out when I do one so I don't get confused on what I've done. Our x-intercept is where you set the whole thing equal to 0. Oh man. Oh, I'm sorry, that's not true. Because this is a rational function, you only set the top. You only set the top equal to 0. Yeah, so that is actually going to work. So x is also, the x-intercept is also 0. And then our vertical asymptote, it's okay if you don't remember how to do it, that's why we're doing this. It's where you set the bottom equal to 0, and then you find anything that makes it 0, and those are your asymptotes, okay? So we're gonna have to factor. We can do a little factor refresher, is that what people say? You want to find what adds to the middle. So what adds to positive 2, and what multiplies to the last and the first guy. So this is a 1 because there's nothing there. So what multiplies to negative 15? And then you can just, oh boy, I wonder what it is. And the way I learned how to do this is with a box. I call him King Box. King Box, because there's other ways to do this that confuse the fuck out of me, and I love King Box. Take your first thing, put put it in your first box, taste your last thing, put it in your last box. And then in these other two, you're going to take these and make sure you remember to put the X because they make an X value, right? Or there's an X next to them. And it's always easier if you take ones that can divide into each other, but for this one, 3 can go into 15 and so can 5, so it doesn't really matter. So then you go down this way, see what they have in common. So they have an X in common, and these have a -3 in common. Now since the negative is closest to the top here, you pull the negative out with it. So if it was this, it would be a +3, okay? I hope that makes sense. And then you go this way and see what they have in common. Still an X, and it's here, it's a 5. So see how this negative is not the closest? So we're not pulling the negative out, okay? We're just keeping it positive. So that's X -3 and X plus 5. And then we always want to check by foiling X times X, X times 5, that would be 5X, -3X is -3 times X, and then -3 times 5 is -15. We combine like terms, and it is the same. So we know we factored correctly. So then we set those equal to 0 when we solve for them. These are our vertical asymptotes, okay? -5 and +3. Horizontal, much easier. Look at your exponents. Look at the degrees. We have n equals 2 and m also equals 2. So when n is equal to m, we do the leading coefficient over the leading coefficient of the bottom. So that's literally just 1/1 because there's nothing in front of this x, so that means it's a 1, right? So it's 1. Our horizontal asymptote is y is equal to 1. Then evaluate. Man, fuck my life. This just takes a long time, okay? It's not that hard. It just takes a million years. Okay. Okay, that's 36. 36 minus 12 minus 15. Always use your calculator when you are ill. Don't get too cocky and think you can do math. So that's 36 over 9, which is 4. Darling, 16. I don't think that can be simplified anymore. Nope. Pretty bad girl. That also can't be simplified any further. Oops. Oops. Okay, 16 plus 8 minus 15. That's 16 over 9. And that can't be simplified anymore. Dogs are children and kiss every one of them. Good night. Holding hands and wiping tears away, she warms them through the night. It's too late. That can't be simplified either. Or it's already in the most simple form it can be in, I mean. Okay. Alright. Your father'd love to be here. On his way. I'm here. Okay. -5, 3, 1. 1. That's -5. That doesn't look like a 5. It looks like an S. 3. Okay, asymptotes are dashed lines, okay? So that is y is equal to 1. This is x is equal to -5. This is x is equal to 3. I need another color. Okay. The parent function is a reciprocal function. You know, it looks like that. Or if you didn't know, you know now. There is no transformations, so nothing's gonna reflect over an axis or any shit like that. God. You know, guys, graphing them actually is still pretty confusing for me because there's hyperbolas and I don't really understand how they work. And I even said that to the teacher, but you guys know how helpful she is. I do know that when you have asymptotes, the lines are always almost touching the asymptotes, but they never actually touch them. It's a mania. Pigments me to grow. So I don't know why it looks like that, but that's what it looks like. Basically, if you can figure out where the asymptotes are and your y and your x intercepts, You can usually figure out which graph is correct just looking at that, because I don't really understand the hyperbolas, and I don't have a teacher that will explain it to me. I just have me, myself, and a book. So those are the big long questions that are on the homework. Let me see if I am missing anything. We can make this love. Okay, I guess let's just do another one, even though I don't want to. Lysomania could clasp you till you grow. Like a ride, oh, not easily offended. Hard to let it go. That's a difference of squares. So this is that thing I talked about for like a second earlier. These two kill each other. This is going to be important when we figure out our vertical asymptotes, because we have a simplified version where x is equal to this, but we have an unsimplified version. Oops. That is also there. So that means this is our vertical asymptote, and this is a hole. I don't know how to say that to you in the math way, but when you simplify it, whichever one is the same, like whichever one is in both the simplified and unsimplified, is your vertical asymptote, and the one that is only in the first guy before simplification, that is your hole, okay? So I just gave you the vertical asymptotes. I'm getting ahead of myself. Like, why would you use fractions and radicals when you're trying to teach a concept? Like, are you trying to confuse people? Like, you can do that after I understand what the fuck I'm supposed to do. Okay? Instead, you just confuse me harder, make me have a mental breakdown, and make me want to give up. Make me tell myself maybe I'm just stupid, but I know I'm not. You just can't fucking teach. I shouldn't even say can't. She doesn't really teach us at all. Okay. First, even is Y symmetry, odd is O symmetry. Fx to f of negative x. Oh, I forgot to write that in a different color. Oops. Oh well. So, anywhere there's an x, put a negative x. Negative x times negative x is a positive x. So we end up with this. Is that the same as the one on top? No, so it's not even. But we don't erase that guy because we need to see if negative f of x equals the same thing. So because we put this negative up on the top here, it has to distribute, okay? So that's why it's not negative 6. These two are not the same. So Once again, this is, wow, that's an M. Neither. To get the y-intercept, you just plug in a 0. Okay, so our y-intercept okay. To find our x-intercept with these kinds of problems, you set the top equal to 0. So our x-intercept is, hold on, I'm looking at my notes and that's not what it says. Oh, right. Remember, I'm messing up so bad. I'm not messing up so bad. You're supposed to simplify it. Remember, I did that earlier, but then forgot that I did that. So this is the one you're supposed to be checking with. So if we set the top equal to 0, is that right? No, girl. One cannot. I shouldn't say that. It's math. 1 cannot equal 0 in this situation. So there is no x-intercepts. Vertical asymptotes. Okay, so before we simplified, we've got x is equal to 6 and x is equal to -6. And after we simplify, we've got x is equal to -6. So our vertical asymptote is this one, and this one is the whole. You've been twisting knives at me, thinking that I'm not gonna see an end. My darkest friend, so cross my heart and hope to die on my side. I'll watch you rot from the inside. Okay, to find our horizontal asymptote, we look for the degree of the exponents on each. Is there an exponent up here? No, there's not. So what that just means is it's 0. Then down here, it's 1. 0 is less than 1. And so our asymptote is y equals 0. You cower down. So inviting you, start denying truths, invigorating. I'm gonna be so real with you guys. I'm not gonna sit here and do that. I have the answers in front of me and I'm just gonna write them down. You guys should try evaluating it by yourself and then double check with what I've got here. And remember, when you're evaluating on my math lab, it usually says to simplify. So don't forget to simplify. I tried to warn you that there is no winning at this game. You're running in these circles with the ones they call insane. It's too late for that now. Jumping in now will save you. Okay. So vertical You might be thinking, how you graph the hole? I will show you. Wow. It's an open circle. Crazy. Okay, and then the parent function is once again a reciprocal function. So because they're asymptotes, that means the lines get close to them. They want to touch them, but they don't. They don't have the confidence. The asymptotes are just too hot, and they're just lines. Okay, so that's what it looks like. I don't know why the one I did before had like 3 of them, and I don't know if I'm ever gonna get an explanation from our teacher about that. Maybe I'll just have to scour the textbook, try to figure it out on my own. Okay. Let me make sure there's not something else I'm forgetting. It wasn't technically a lot, it was just those 3 sections, but they made the one section so confusing that you just, or at least I didn't know what the hell I was doing, especially with these 7-part problems. It didn't really explain the whole thing super well. Okay, so let me just try to do a little review here. For vertical asymptotes, let me get an example here. For vertical asymptotes, we take the bottom, the denominator, and we set it equal to 0. So in the case of this one, so our vertical asymptotes would be for horizontal asymptotes, you're just looking at the exponent. And so you're looking at the degrees. Okay. Now, if we had you're supposed to simplify. So, since we have a difference of squares, I gave the 3 some personality. So then with a vertical asymptote, you still set the bottom equal to 0 before we simplified. And then after. The one that shows up twice is your vertical asymptote. The one that's on his own, that's the hole, okay? That's the hole. And then the vertical asymptote for this one, I'm sorry, horizontal asymptote. Or wait, Oh, I messed up the last one, didn't I? I was supposed to divide it. I'm so sorry. I hope I did not just confuse anybody. Okay. Or maybe it was a test. Maybe I was testing you. Okay. And then, how did they write this? Hold on, I'm looking at my notes. I know they wrote this in a specific way. It's everything. It was like PX and QX or something. Where is it? Oh, there it is. Okay. And then there was some questions that were like, they would show you a graph, and then it would say if f of x is this, apparently in math, an arrow means approaching. If f of x is approaching negative infinity, then it would ask you what something else is approaching based on that. And I can't really show it to you because I don't have the graphs on here. I don't think I wrote that one down because you don't have to write anything down. Did I? Is that okay? Maybe. Here. I'll write this down just in case it helps someone. Sorry, my sister-in-law is sick. Yeah, she has bronchitis, so I guess the lesson here is always ask your grandparents if they're feeling unwell before they fucking hug you. Okay, this is what I was trying to explain with words. So the question you'll get will be like, as x approaches infinity, f of x approaches, and then they'll want you to put in what b is, okay? So if this was 1, you would put 1. Or maybe y equals 1. I can't super remember. I'm sorry. Okay. I think that's it. Let me make sure I'm not forgetting anything. Nope, I don't think I'm forgetting anything, but yeah, okay, alright. Bye.